Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we will do one more question related to the applications of the integrals. Now let's take a question from exercise 8.2, and the question is: find the area of the circle 4x square plus 4y square equal to 9, which is interior to the parabola x square equal to 4y. That is, we have to find area between these two curves. Let us find it. Now, to find area of the circle which is interior of this parabola, we'll first draw the circle and the parabola. Now from this equation we can write x square plus y square equal to 9 by 4, or x square plus y square equal to 3 by 2 whole square. Okay, now this is the circle with center at origin and radius equal to 3 by 2. So let us draw this circle. Okay, now its radius is equal to 3 by 2, or 1.5. Now we will draw this parabola. The parabola is x square equal to 4y, so its axis is along positive y-axis. So it is like this. Also its vertex is at origin, so we can draw this parabola as it's like this. Okay, now we have to find area of the circle which is interior of the parabola x square equal to 4y. That means we have to find this area. Okay, since the circle and parabola, they are symmetric about this y-axis, so if we find this area, that is the area in first quadrant, then the total area is equal to 2 times the area in the first quadrant. Okay, now we will find this area, the area in the first quadrant. Now it is here origin, that is 0, its coordinates are 0, 0. Now first we will find this point, that is point of intersection of the parabola and the circle. Okay, for that we will solve these two equations, that is equation, let us name this as equation first, this as equation second, and this as equation third. Now substitute x square from equation second in equation third. We get, instead of x square we have 4y, get 4y plus y square equal to 3 by 2 whole square, or it is 4y plus y square equal to 9 by 4, or it is 4y square plus 16y minus 9 equal to 0. Now we will solve this quadratic equation to get y. Now we can write y is equal to minus b, that is minus 16, plus minus square root of b square, that's 16 square, which is equal to 256. 256 minus 4 into a, that is 4, into c, that is minus 9, so that is equal to 144. It is minus 4 is c. Since minus this 9 is minus, so we get minus minus is plus. We get 4 into 9, that is 144. Okay, divided by 2 into a is here 4, So 2 into 4 is equal to 8. So we can write here 8. Or it is y is equal to minus 16 plus minus square root of, that is 256 plus 144, that is equal to 400 divided by 8. Okay? That further imply y is equal to minus 16 plus minus, it is square root of 400, that is equal to 20 divided by 8. So y is either minus 16 minus 20 by 8 or minus 16 plus 20 by 8. But here y cannot be negative, y is positive at both points, here and also here. Y is positive. So we have to take this plus sign, so we can, from that we get y is equal to minus 16 plus 20 divided by 8. And that is equal to 20 minus 16, that's 4. 4 divided by 8, that is equal to 1 by 2. So we get y is equal to 1 by 2. Now substitute the value of y in equation third, we get x. Okay? Now using y equal to 2, sorry 1 by 2 in equation third, we get x square plus, now instead of y square we can write 1 by 2 square, it's 1 by 2 square plus, sorry, equal to, it is 3 by 2 whole square, that is 9 by 4. So it's x square plus 1 by 4 equal to 9 by 4, or x square equal to 9 by 4 minus 1 by 4. So 9 by 4 minus 1 by 4 is equal to 8 by 4, and that is equal to 2. So x square equal to 2, therefore x equal to plus minus square root of 2. Okay? Thus the points of intersection are, here we have x is square root of 2 and y is 1 by 2, and here it is square root of minus 2 and y is 1 by 2. Okay? Now we draw perpendicular from this point on x-axis. Okay, let this point be point M. Then coordinates of M are square root of 2 comma 0. Okay, and this is origin, so its coordinates are 0 comma 0. Now we have to find this area, that is area in the first quadrant. We will integrate from 0 to square root of 2, and we'll first find area under this curve, that is under the circle, from 0 to M. Then we'll get this area. Okay, the whole area, this area plus this area. Then we will subtract, from this we will subtract the area under this parabolic curve, that's from 0 to M, that means this area. Okay, the whole area minus this area is equal to this shaded area. Okay, shaded area in first quadrant. Now, area of shaded region in quadrant first is equal to, it is integral from 0 to square root of 2 area under this circular curve, that is this. So here we get from this equation, we can write y is equal to 3 by 2 square minus x square. Okay, so y is equal to square root of 3 by 2 whole square minus x square. So it is from 0 to square root of 2, and here we write instead of y we have 3 by 2 square minus x square dx. So this is the area under the circle from 0 to square root of 2, or from origin to m. Okay, that is this area. Then from this area we will subtract minus this area, that's area from 0 to square root of 2, area under parabolic curve, that is this, y is equal to x square by 4, or y is equal to 1 by 4 x square dx. Okay, so this is the area of shaded region in quadrant first, that is this area. This area minus this area is equal to this area. Now we can write a is equal to, its integral from 0 to square root of 2 square root of 3 by 2 square minus x square. It is of the form a square square root of a square minus x square, and that is equal to x by 2 square root of, it is 3 by 2 square minus x square, then plus a square, that is 3 by 2 square divided by 2 sine inverse x by a, that is x by 3 by 2, and the limits are from 0 to root 2. Okay, then minus, it is 1 by 4 is constant, and integration of x square is x raised to power 3 by 3 with limits from 0 to square root of 2. Okay, that is further equal to, now applying the limits, when we put x equal to square root of 2, we get square root of 2 divided by 2, then square root of, it is 3 by 2 whole square, that's 9 by 4 minus square root of 2 whole square, that's 2, then plus, it is 9 by 4 into 2, so it is 9 by 8, then sine inverse x is equal to square root of 2, so we get 2 times square root of 2 divided by 3. Now we give this lower limit to it, and when x is 0, this whole becomes 0, and this also sine inverse 0 is 0, so the whole becomes 0. Then we have minus, it's 1 by 4. Now apply limits, it is x raised power 3, so we get square root of 2 raised power 3 divided by 3. Then we give this 0, and when x is equal to 0, this becomes 0. Now this is further equal to it's square root of 2 by 2, and it is 9. 4 into 2 is 8. It is 9 minus 8 divided by 4, that is 1 by 4. So this is equal to square root of 1 by 4 is equal to 1 by 2. Okay, then we have plus 9 by 8 sine inverse 2 root 2 by 3. Then we have minus times, it's 2 raised power 3 by 2, 2 raised power 3 by 2, 4 into 3 is 12, divided by 12. Or we can write it as, we can take square root of 2 common from here, from these two. So we can write a equal to, it is square root of 2 divided by 4, take it common, then here we have 1 minus, it is 2 by 3. Okay, then plus 9 by 8 sine inverse 2 root 2 by 3, or a is equal to, it's square root of 2 divided by 4, it is 3 minus 2, that is 1 by 3, so it is 1 by 3 plus 9 by 8 sine inverse 2 root 2 divided by 3. Now area of the shaded region, this area plus this area, is equal to 2 area. Okay, so the total area of shaded region, so area of shaded region equal to 2 times A. So that is equal to, it is twice, it is root 2 divided by 4 into 3, that's 12, plus 9 into 2, that is 18, divided by 8, sine inverse 2 root 2 divided by 3, or its 2 ones are 2 6s are, it is root 2 divided by 6 plus, it is 2 4s are, it's 9 by 4 sine inverse 2 root 2 divided by 3. Okay, square units. So this is the area of this shaded region, that is area of this plus area of this. Okay, and that completes the question. Now in my next lecture we will do few more questions related to the areas between two curves. Till then, take care of yourself. Thank you.